Hello students, welcome to Vyas Edification Kota. In this series of NCERT discussion, we are continuing further with the chapter from Mathematics class 11, that is Permutations and Combinations. The interesting permutations and combinations, and today is the turn of exercise 7.4. So let's begin the first question over here. Let's solve this question. The question says if NC8 is equal to NC2, find NC2. Okay, and what are the results that we have related to this NCR? We have a certain result that says NCP equals NCQ if it is given. This implies that either P will be equal to Q or P plus Q will be equal to N. These are the two results that we have, and this happens because NCR is also equal to NCN minus R, right? This happens because this is true. NCR is equal to NCN minus R. Because of this, that particular thing happens. So let's apply that concept over here and see NC8 is equal to NC2. This implies that either 8 is equal to 2 or 8 plus 2 is equal to N. This implies this or this. And you can clearly see that 8 is not equal to 2. Since 8 is not equal to 2, we can clearly observe that N will be equal to 8. Once we find N, the next thing that is asked is NC2. Therefore, NC2 will become equal to, N is equal to 10 is what we'll get, right? Not 8 over here. Let's make that correction. Yes, this is 10. So this becomes 10C2, right? 10C2, and what's the value of 10C2? This is 10 times 9 over 2 times 1, which is 45. And that is my answer for this question over here. 45, yes, that's the answer for this question over here. Let's discuss this question next. The question says that determine N if 2NC3 is to NC3, the ratio is equal to 12:1. Okay, if this is the case, then let us apply this idea. 2NC3 over NC3 is equal to 12/1. This implies what? Now 2NC3, what is 2NC3 equal to? This is equal to 2N factorial, okay, over 3 factorial 2N minus 3 factorial times denominator has NC3, which will be actually N factorial, and here you'll have 3 factorial, here you'll have N minus 3 factorial. Is that okay? Yes. And this ratio is equal to 12/1. This ratio is equal to 12/1. Now let's see where does that take us. So 3 factorial goes with 3 factorial. This gets cancelled. And 2n factorial, 2n minus 3 factorial. There are a few extra terms over here. What are those? 2n minus 1, 2n minus 2, and next term would be 2n minus 3 factorial, which gets cancelled with this 2n minus 3 factorial. What about this term? N factorial and n minus 3 factorial. N factorial is greater, so n, this term will be there, n minus 1 will be there, n minus 2 will be there, and after that n minus 3 factorial will get cancelled with this one. And this here is equal to 12/1. Let's see, this n goes with this n, okay, and what else? This 2 cancels this 12, there will be a 6 over here. Now, let's observe, this is the product which we have in the LHS, and this will go in the RHS. This becomes 4n square, 2n into 2n is 4n square, minus 4n minus 2n will become minus 6n, and plus 2 is equal to, what do we have? 6 times, you have n square minus 3n plus 2 in the RHS. Do you observe that? Yes. Please observe there is a factor of 2 coming out common from here. Yes, we can cancel that factor, and what will remain is 2n square minus 3n plus 1, which is equal to what? The factor of 2 gets cancelled with this 6. What remains here is 3. 3 times n square minus 9n plus 6 is what I get. Okay, let's create the quadratic. Let's see what's the quadratic that we are getting. This gives me n square, okay, minus 6n, okay, plus 5 is what I get. And from here I can observe that n equals 1 or n equals 5. Now you can clearly observe one thing. What do we observe? That for defining NC3, n should be at least 3. So n equals to 1 is not okay. This is rejected. N equals 5 is accepted, as you can see over there. So n equals to 5 is my correct answer for this question over here. Let's talk about the next question. This says determine n if 2nc3 is to nc3 is equal to 11 is to 1. Okay, what happens in this case? Let's solve this question. This is 2nc3 over nc3, which is equal to 11 upon 1. Okay, we just solved 2nc3 upon nc3 in the previous part of the same question, and what did we get over there? This is 2n minus 1, 2n minus, sorry, there was a 2n as well. Don't forget that 2n. Things begin with 2n, right? So let's begin with that 2n, 2n minus 1, 2n minus 2. Okay, and you'll have 3 to 1 in the denominator of this. Similarly, for nc3, you'll have n minus 1, n minus 2, right? You can go a step back and see the solution of the first part, in which we have calculated this LHS to be equal to this. This is equal to 11 upon 1. Is that okay? Yes. This n goes with this n. Okay. And what do we get in the numerator? In the numerator, you get a lot of things. This is 2n times 2n. 2 is outside. This is 4n square minus 6n plus 2 in the LHS. In the RHS, you have 11 times this factor, which is n square minus 3n plus 2. Right? This is what you have. Let's multiply and create a quadratic. This is 8n square minus 12n plus 4 is equal to 11n square minus 33n plus 22. This is what you have, right? And after this, let's take everything on the right hand side. This becomes 3n square, 12n minus 33n. What will that be? Minus 21n, and 22 minus 4 is plus 18 equals 0. This is what I get. Dividing by 3, we get n square minus 7n plus 6 equals 0, and this gives me n equals 1 or n equals 6, right? Factoring the middle term, right? As 6 and 1, this will give me n equals 1, and remember the previous question also we rejected this n equal to 1 because n should be at least 3, right? For defining nc3, n should be at least 3. So therefore the correct answer for this question is n equals 6. That's the correct answer for this question over here. Let's move on to the next one after this. Question 3 says, how many cards can be drawn through 21 points on a circle? Okay. Now if there are 21 points on a circle, what can you do? How can you find the number of cards? Let's see. Let's begin with a smaller number to get the idea. Let's begin with a smaller number of points on the circle. Let's say this is the circle. There's one point over here. Let's say there's another point over here, there's another point over here, and there's another point over here. Let's say there are only 4 points. To understand the concepts, let's see there are only 4 points. If there are only 4 points, then let's try and draw the chords. What are the chords? You will join this with this. This will be a chord. You will join this point with this point. This is another chord. You will join this point with this point. This is another chord, right? Next, you will begin with this one. Okay. And you will begin with this one. Next, you will join these as well. Right. So what do you observe? You observe that for a chord, what do you need? You need 2 points on circle. Any 2 points on the circle can be joined to give you a chord, right? You just need how many points? 2 points to create a chord, right? So out of these 4 points, how many chords did you create? 1, 2, 3, 4, 5, 6. 6 chords. And is that also equal to something else from the point of view of combinations and permutations, let's say? So if you observe that we just need 2 points out of how many points? There are a total of 4 points, and out of 4 you need to choose any 2 points. Is that? Yes. What's the value of 4C2? 4C2 is 4 times 3 over 2 times 1, and this is equal to, yes, 6. Oh, so instead of counting it directly like this, I can also write the answer as 4C2, right? You choose 2 points out of the 4 points available on the circle. You choose 2 points, right? And you get the number of chords easily. So now in this question, when the person has said that there are 21 points on the circle, lot of points, right? There are a total of 21 points. So what will you do? For number of chords, the simple thing that you need to do is simply select 2 out of 21 points. And on selecting any 2 points, you get a chord, right? So 21C2 will be equal to the number of chords. That's what you'll get. And what's that equal to? That's 21C2 can be calculated. This is 21 times 20 over 2 times 1, which is 210. That is my answer for this question over here. That's the number of cards that you have in case you have 21 points on the circle in this manner, right? The idea is as we have discussed over here. That's all in this question. Let's move on to the next one. This question number 4 says, in how many ways can a team of 3 boys and 3 girls be selected from 5 boys and 4 girls? Right. So we are supposed to select a team, we are supposed to form a committee. In all of those cases, we use a similar idea. That's we select certain number of people, right? In how many ways can a team of 3 boys and 3 girls? So we are supposed to select 3 boys and 3 girls, okay, and from 5 boys and 5 girls. 5 boys and 4 girls, not 5 girls. We have 4 girls over here, okay. So select this many out of this. Out of 5 boys and 4 girls, select 3 boys and 3 girls. And how do you do that? So for selecting boys, we have to select 3 out of 5. Choose any 3 out of those 5. Choose any 3 out of those 4. This is 4C3, right? And 5C3, 4C3, you have to do this and this. You have to do this and this. The task is only complete after you select this and this. Therefore, we apply the fundamental theorem of multiplication as well, right? Fundamental theorem of counting says this is what you are supposed to do. So 5C3, what is the value of 5C3? 5 times 4. 5C3 is same as 5C2, yes. So this is 5 times 4, 2 times 1 times 4C3, which is 4, simply 4. And this will be equal to 10 times 4, which is 40. So there are 40 ways to actually select a team of 3 boys and 3 girls from 5 boys and 4 girls. That's the answer for this question. Let's move on to the next one. Let's discuss this question next. The 5th question says, find the number of ways of selecting 9 balls from 6 red balls, okay, 5 white balls and 5 blue balls if each selection consists of 3 balls of each color. Okay, so that's an interesting question, since here we have 3 possible things out of which we are supposed to choose. Selecting 9 balls. So you are supposed to select 9 balls. Okay, out of how many? Out of you have 6 red balls. Okay, let's mark red by R. Okay, and 6 red, 5 white and 5 blue balls are there. You have to select 9 balls if each selection consists of, now this is an interesting one, if each selection consists of 3 balls of each color. Now there's a condition given on each selection, right? So 3 red, 3 white and 3 blue should be selected. Now ways of selecting 3 red out of 6 red would be 6C3. This is what you'll do. Ways of selecting 3 white out of 5 white will be 5C3, and ways of selecting 3 blue out of 5 blue will be 5C3. Let's multiply them together as per the mandate of fundamental theorem, right? And now this is the number of ways. Number of ways will be simply this. Okay, can you calculate this value? That's pretty simple. 6C3 will be 6 times 5 times 4 over 3 times 2 times 1 into 5C3. 5C3 is same as 5C2. This is 5 times 4 upon 2 times 1, and there's another 5C3, so you have 5 times 4 over 2 times 1 again. This is 2, this is 2. This overall is 10, this overall is 10, which is very simple. This 3 times 2 goes with 6. This is 5 times 4 is 20. Okay, and you have extra 0, that's the correct answer for this question. That is, you have 2000 ways of making this kind of a selection, right? This is what you have. Is that okay? Yes. That's a pretty simple one. Let's move on to the next one after this. Let's discuss this question next. The question says, determine the number of 5 card combinations out of a deck of 52 cards, okay, if there is exactly 1 ace in each combination. Now, how do we handle this? We have 5 card combination. We have to select 5 card combinations containing exactly 1 ace out of 52 cards, right? So how many aces are there in a deck, full deck of 52 cards? So we have 52 cards, and out of these there will be 4 ace cards plus there will be 48 other cards, right? There will be kings, queens, and lot of others, right? Ones, twos, threes, lots of other kinds of cards. Ones, aces are ones, right? Okay, twos, threes and fours, there will be a lot of other cards. You have to select 5 cards out of these, and exactly one ace should be there in this combination. So one ace has to be selected, and out of 5 cards, one is an ace, 4 other cards will need to be selected over here, right? So number of ways, what will be the number of ways? Number of ways will be simply equal to this. Please observe. Select 1 out of 4, that will be 4C1. Select 4 out of 48, that will be 48C4. Okay, and by the fundamental theorem, yes, they will have to multiply this. This is the number that we are getting. Now 48C4, it is a big number, right? 48C4 would involve a lot of big numbers. But let's see where does that take us. One of the ways, maybe the person asking the question may require the answer up till this stage only, but then the NCERT people, they're adventurous, right? So let's solve this further and see where does that take us. The 4C1 is simply 4. 48C4, what is that equal to? So 48 times 47, 46, 45, and in the denominator you have 4, 3, 2, 1. This 4 goes with this 4, that is done. And what else? 3 times 2 is 6. This is 8 over here. This is what I'm getting. Okay. What else? 45 times 46 times 47. Can we multiply them together? Yes. 8 is okay. What is 47 and 45? This is actually 46 plus 1, 46 minus 1, right? Let's observe. 46 plus 1, 46 minus 1 is actually 46 square minus 1. When you multiply with this 46, this will become 46 cube minus something. But let's calculate 46 square minus 1 first. What is 46 square? This will be equal to 16 at the end, and 2116 minus 1. Yes, this is what I'll be getting, 2116 minus 1, and this will be 2115. This is what I'll get. Okay, and we'll have to multiply this with 46 as well. Okay, let's multiply this with 46. I have a 2 as well, and that will convert to 4230. Right, let's write it as 2115 times we have 46 again. Okay, and what will this be equal to? This is, let's multiply this 8 over here, and what does that take us? 8 times 5 is 40, 0, you get a 4, 12, 2, you get a 12, that's 1, 9 and 16. 16920 times 46 is what I have over here. So let's multiply 1692, 46. Now how do we find that? Let's multiply them. And 1692 times 46. 6 times 2 is 12. Okay, 2, you carry forward a 1. 9 times 6 is 54, plus 4 times 2 is 8. This is 62, plus 1 is 63. 3, and you carry forward a 6. Okay, 6 times 6 is 36. 9 times 4 is also 36. 36 is 72. And a 6 will be 78. 8, and you carry forward a 7. Right? And what else? Then you get 6 times 1 is 6. 6 times 4 is 24. 24 plus 6 is 30. 37 is what I get. 7, and you carry forward a 3. Then you get 4 times 1, which is 4. 0 and 0, 4 plus 3 is 7. This is what I'll be getting. 7, 7, 8, 3, 2. 7, 7, 8, 3, 2, 0. Yes, this is the final answer for this question over here. 7th. This question says, how many ways can one select a cricket team of 11? Okay, we are supposed to select a cricket team of 11 from 17 players in which only 5 players can bowl if each cricket team of 11 must include exactly 4 bowlers. Okay, so out of 17, what do you have? You have 5 bowlers plus 12 other players, right? And you have to select 11 which contain 4 bowlers, exactly 4 bowlers, right? Exactly 4 bowlers, and what else? 7 other players, right? Since total 11 have to be selected, 4 bowlers and 7 other players will be selected. Out of 5 you have to select 4, this is 5C4. Out of 12 you have to select 7. So this is 12C7, and this is the number of ways. Total number of ways will be the product of this and this, right? This is what you get. Is that okay? Yes. This is 5C4, which is simply 5. 12C7 is same as 12C5, right? So this will be 12, 11, 10, 9, 8 over 5, 4, 3, 2, 1, right? 5 terms in the numerator, 5 terms in the denominator. 5 times 2 goes with 10, this goes, okay. 4 times 3 goes with this 12, okay. And what remains is 5, 11, 9 and 8, okay. And 8 times 5 is 40 times, this is 99. What is this equal to? This is 99 times 4 is 396. This is 3960, and yes, that is the answer for this one. 3960 is the final answer. That's the number of ways of selecting a cricket team of 11 out of these 17 players. That's all in this question. Moving on to the next one after this. Question number 8 says a bag contains 5 black and 6 red balls. Okay, 5 black and 6 red balls. Determine the number of ways in which 2 black and 3 red balls can be selected. Once again, a pretty simple question. 5 black balls, 6 red balls. You have to select 2 black and 3 red balls. Okay, let's make that selection. This is 5C2, this is 6C3, and you have to multiply to get the number of ways of making this selection. 5C2, the value of 5C2 will be 5 times 4 over 2 times 1 into 6C3 will be 6, 5, 4 over 3, 2, 1. 3 times 2 is 6, gone. 2 times this is gone. 20 times 10 is 200. This is 200 ways, and that's my answer for this question. It's 200 ways, and that's the final answer for this question over here. Moving on to the next one. 9th question says that in how many ways can a student choose a program of 5 courses? Choose a program of 5 courses if 9 courses are available and 2 specific courses are compulsory for every student. So out of 9 courses, 2 are compulsory, okay, and 7 other courses are available, okay. You have to select 5 courses. A student has to select how many courses? 5 courses. These 2 are compulsory, means they will be surely selected. So 2 compulsory and remaining 3 courses out of these. So this is only one type of selection. This is only one, and this is 7C3. That's the number of ways of selecting this. 7C3 will be 7, 6, 5 over 3, 2, 1. 2 times 3 is 6. This is 35 ways to select the courses, right? That's what you have over here in this question. With this, we come to the conclusion of this exercise over here. This exercise which we have solved based on combinations, right? This is exercise number 7.4 from the chapter Permutations and Combinations, and questions related to combinations have been discussed over here.